Alright, so the first step in the synthesis of this polypeptide is transcription from the DNA into mRNA. The mRNA polymerase separates the DNA and creates a strand of RNA nucleotides. The next step is translation. The mRNA goes to a ribosome. tRNA bring amino acids and attaches the codons on the mRNA, and the polypeptide is assembled. If there's an insertion or deletion in the DNA, there is a huge effect on the RNA and the resulting polypeptide. If an amount of nucleotide pairs is inserted that is not divisible by 3, a frame shift happens, as you can see here. All of the codons will be messed up after the mutation occurs, and the polypeptide will be completely different because different amino acids will be coded for. And the same thing happens with a deletion, different amino acids and a different polypeptide. So the effects of the insertion or deletion, it results in a frame shift, which messes up all the codons, and it makes a completely different polypeptide that won't be able to function correctly because it'll fold differently, and oftentimes these mutations result in a premature stop codon. So if there's a substitution mutation, there can be no effect at all, or an effect. So in a silent mutation, there's no effect, and the amino acids are still coded for the right way, and no change occurs. In a missense mutation, a substituted nucleotide causes there to be a different amino acid to be coded for, which will cause the polypeptide to fold differently and not function well. And in a nonsense mutation, a substituted nucleotide causes a premature stop codon. And yeah, so the effects of substitution: there can be no effect at all, which is a silent mutation. There can be a different amino acid coded for, which is called a missense mutation, and this will cause the polypeptide to fold differently and not function right. And there can be a nonsense mutation, which causes a premature stop codon, and the polypeptide will be too short and not function right. And yeah, the end.